Welcome to another fascinating video. Today, we're diving deep into the mysterious realm of dark matter, the invisible substance that makes up most of our universe. We'll uncover its role in shaping the cosmos and explore how scientists have been unraveling its enigmatic properties. So, let's dive in and don't forget to subscribe to be part of this revolution. Dark matter is a mysterious form of matter that doesn't interact with light, making it invisible to telescopes. Although it doesn't emit, absorb or reflect light, it does have a gravitational pull on other objects in the universe. It's estimated that dark matter makes up about 27% of the universe's total mass energy content, while ordinary matter, like stars and planets, only accounts for about 5%. The concept of dark matter dates back to the 1930s when Swiss astronomer Fritz Zwicky discovered that the mass of galaxy clusters was much larger than the visible matter within them. In the 1970s, American astronomer Vera Rubin's work on galaxy rotation curves further supported the existence of dark matter. Since then, numerous observations of galaxy clusters, gravitational lensing, and cosmic microwave background radiation have provided strong evidence for the presence of dark matter. Scientists are using various approaches to study and detect dark matter. One popular theory is that dark matter consists of weakly interacting massive particles, WIMPs. These hypothetical particles rarely interact with ordinary matter but have a strong gravitational influence on the cosmos. Experiments like the Large Hadron Collider, LHC, and the Xenon Dark Matter Project, Xenon, are searching for direct evidence of WIMPs. Another candidate for dark matter is the action, a hypothetical particle that's much lighter than WIMPs and could be detected using sensitive detectors like the Action Dark Matter experiment, ADMX. Furthermore, alternative theories like modified Newtonian dynamics, MOND, propose modifications to our understanding of gravity to explain the observed behaviors without relying on dark matter. Dark matter plays a crucial role in the structure and evolution of our universe. It's believed to be responsible for the formation of galaxies, as its gravitational pull draws ordinary matter together into clumps. Without dark matter, the universe would likely be a barren place with few, if any, galaxies, stars, or planets. The study of dark matter not only helps us understand the fundamental nature of the universe but also sheds light on the very nature of matter itself. So what we have seen so far. Dark matter, an elusive and invisible substance, makes up approximately 27% of the universe's total mass energy content. Its gravitational effects have been observed through galaxy clusters, gravitational lensing, and cosmic microwave background radiation. Pioneers like Fritz Zwicky and Vera Rubin have laid the groundwork for our current understanding of this mysterious phenomenon. Currently, various experiments and theories are underway to detect and study dark matter, including the search for WIMPs and axions, as well as alternative theories like modified Newtonian dynamics. These endeavors aim to shed light on the nature of dark matter and its role in shaping the cosmos. Dark matter's impact on our universe is significant, influencing the formation of galaxies, stars, and planets. Its study is essential for understanding the fundamental nature of the universe and the building blocks of matter itself. In conclusion, while dark matter remains one of the most enigmatic subjects in modern astrophysics, our continued exploration and research efforts bring us closer to unveiling its mysteries. As we uncover more about dark matter, we deepen our understanding of the universe and our place within it.